In the name of Allah, we are going to present our paper with title Simulation and Application to Survivor Analysis of Neck Cancer Disease with New Probability Distribution. The authors, me, Dr. Saeed Hemeda, and Dr. Aysam al-Basyuni, and Dr. Muhammad Siyar. Contents: abstract, introduction and literature review. The new work, it is Shine Inverted Exponential Distribution. After that, application, and the last topic is conclusion. Abstract. In this paper, we introduce a new probability distribution, which is combining between two probability distributions. This distribution uses two various properties of the proposed distribution, including explicit expressions. We introduced explicit expressions or mathematical expressions for some mathematical properties for the new probability distribution, and we proved in some simultaneous and application of survivor analysis to real data, that is the neck cancer disease data. Introduction and literature review. In many applied areas such as lifetime analysis and other fields, there is a strong need to develop the classical distributions like Weibull, binomial, and so on. So different methods to generating new probability distributions. Why? Because to fit more data. These include some examples for new probability distributions like Azzolini skew family by Azzolini 1985 and Beta G family by Agent et al. 2002. The new work is Shine Inverted Exponential Distribution. It's a combination between Shine probability distribution, Shine its hyperbolic sine distribution, and inverted exponential distribution. Okay? Generating of our model, we use the hyperbolic sine Shine family with commutative CDF and probability function BDF to generate the CDF of the new probability distribution. That's in equation number 1, and the BDF in equation number 2. Okay. Also, we find the hazard rate function and the survivor function. That's in equation 5 and 6. The graph of BDF probability function of our probability distribution, that's at left, and the graph of CDF cumulative probability distribution, that's at right, for selected values of parameters. Like in figure 1. Figure 2, this represents the survivor and the hazard functions for selected values of parameters. Some statistical measures, we computed the Rayleigh entropy function. Rayleigh entropy function, it's important to uncertainty measure and randomness of a system and are used in information theory. And we computed also moment generating function, that's this equation. And the moments about mean. After that, the mean residual of distribution. Also, we find mathematical form with closed form for quantile function that's used to simulate random numbers using this equation. And the last measure is the skewness and the kurtosis coefficients by the two formulas. This figure of hyperbolic Shine function with selected values, quantile function. Estimation of parameters. We estimated the parameters of the new probability distribution using the maximum likelihood estimation, the log likelihood function of Shine inverted exponential distribution with abbreviation SIED takes the last four. Simulation study. A simulation study is carried out to investigate the performance of estimators for SIED distribution in terms of their Bayes mean square error using maximum likelihood estimation method. Okay. Simulation study. We generated samples of size n with samples n equal 30, 50, 100 from the new probability distribution and generated, and the parameters are estimated using the maximum likelihood estimation method. 10,000 such repetitions are made to calculate the Bayes and the mean square error. That is the result in table number 1. Follow table number 1. And the real data, that's the cancer disease application. We apply using real data to the new probability distribution. This real data, and find some mathematical statistical measures like Konogrov-Semnorov, KS, and AIC, Archaic Information Criteria, and Bayesian Information Criteria. We find definitive this data set and compared these measures by two another probability distributions with Weibel W and inverted exponential IE. From the results, we find that the BIC and the AIC of our probability distribution, Shine inverted exponential distribution, is the smallest value than Weibel and the exponential. That means the new probability distribution is more applicable for this data. It's more fitting for this data. That is the figure estimating the BDF and CDF models with the histogram of the real data. Conclusion: the main aim for generating new probability distribution is to make more flexibility to the distribution so that more data can be analyzed using the new distribution. Important statistical measures such as moment-generated function, quantile function, and mean deviation are discussed with closed mathematical form. Furthermore, entropy measures are determined. The model parameters are estimated using the maximum likelihood estimation. Thank you very much.